what I'm going to look at today is problem sets. How I generate them, how I use them, all of that sort of idea. So when I think of a problem set, what I'm thinking about is a few questions, maybe 5, 6, that I assign to students bi-weekly, or about that amount. So they've got about 2 weeks to work on. It's a fair amount of time to work on these problems, and these are fairly challenging problems. I love these for a lot of reasons. And one of the things I love to see is when students work together, help each other out with these. I find that's a great way for students to sort of generate knowledge between them and all of those wonderful outcomes. Now, the problem with a problem set and students working together is that sometimes students will end up basically copying each other. They won't be doing the work themselves, and then we've got a whole thing. Part of that's just intellectual dishonesty, but most of it I actually think is just it's really hard if you've already solved a problem to help someone with it without giving away that answer. I think that's a real skill that I don't think students have necessarily mastered. So ideally, what I think we want is each student to have a different version of the same problems. Then they can help each other out, but they don't quite know exactly how their friend's version is going to come out. So they can say, oh, maybe you should try doing whatever in this, and without giving, oh, the answer is 23. That's the goal. So how do we do that? How do we make different versions of a problem set for each student? And also then, how do we mark that efficiently? Because going through and marking each completely different problem, that's going to be way too time consuming to meaningfully mark. Occasionally there's probably times where that works out. Sometimes I will give problems where students sort of generate their own, but on a day-to-day basis that's probably going to get overwhelming. So what we want is to generate a whole bunch of versions of a problem and be able to mark them efficiently. Solution to both of these is going to be to use Excel. At least that's my solution. So let's take a look at this example problem I've got right here. A company produces pencils. They each weigh 5.8 grams each. They produce 2.3 times 10 to the 6 pencils each day, and they load them into bins which hold 100 pounds of pencils. How many bins of pencils does the company produce each year, assuming they produce all days of the year? Nice question. It's got a bunch of pieces here that I like. It's got sig figs, it's got unit conversion, it's got scientific notation, it's got a whole bunch of pieces we got to put together when we're multiplying. It's got a lot of stuff going on here. So I kind of like this problem. It's a nice problem I use in intro physics classes. Okay, so key thing is there's a few numbers that are kind of arbitrary here that we can change whenever we feel like, and it's not going to really change the problem or make it too much more difficult. Okay, first of all, the mass of each pencil, 5.8 grams, that could be changed. The number of pencils produced each day, sure, we can change that. And finally, the amount of pencils that go in each bin, all of those can be changed. Now, I'm not going to change the number of days in a year or the number of grams in a pound. That would be silly. Okay, so what I've seen is there's basically 3 things I want to change here. Now, notice over here, this is actually an equation I've got set up here. I could change any part of it. I could change the exponent here. I'm not going to. I'm just going to change the number in front right here. That's going to be my goal. And so let's say 3 things we want to change in each of these. Okay, so each version will be exactly the same except for this number, and this number right here. So let's go over to Excel and set that up. So first thing I'm going to say is version. I want to have some number in my Excel that corresponds to the version of the problem that I'm dealing with. So I'm going to say version 1, version 2. Now Excel is super cool. I can select 2 things and then I can drag it down. I would go all the way down to 26. And it notices the pattern 1, 2, what comes next? 3, it thinks, and it's right. And it goes all the way down. So those are my versions. I like that. Perfect. Okay, what was the first field I wanted to fill in here? It was the mass of each pencil. Okay, mass. So I'm going to say equals. Now, the function I'm going to use a whole lot here is rand between. Rand between. Now, I don't really know what a pencil weighs. Between, I don't know, say 5 and 8 grams seems reasonable to me. 5 and 8. So this is going to create a random integer between 5 and 8. And now because I have something in the left-hand side from this, I can double-click here, and you can see it fills it in right there. Okay, that's not bad. That's fine. 6, 7, 8, 6, 5. That's good. But I actually want 1 decimal precision here. So I want one more piece of information here. So I want it to be like 8.3 or whatever or something like that. So I'm going to say between 50 and 80, and I'm going to divide that by 10. See? Now that gives me 6.7. I love that. Perfect. Okay, perfect. And the ones that are coming out just 8, that's actually 8.0, and we'll deal with that later on. Okay, perfect. So that's the mass there. We've got the number of pencils. I'm going to do similarly equals rand between, let's say, 20 and, let's make it 50. And we'll divide that by 10 as well. And again, I can now double click here and we'll just fill in this formula all the way down. Notice each of these is a random and it will be updated every time I do anything in this. So we got the mass number and then we got the bin size. Now for the bin size, I'm thinking, I probably don't want randomly like 83.2 pounds per bin. I probably want nice kind of whole numberish things. I don't know, this seems right for me in this problem. So I'll say equals rand between, I'm just going to say between 3 and 6, and then I'm going to say times 20. So it's going to generate some number, 3 to 6, so it's either going to be between 60 and 120 pounds in intervals of 20, which is, I think, nice. Okay, so I've got a whole bunch of numbers here. It's fairly unlikely any problem is going to be exactly the same in all 3, which will mean the answer in each question will be distinct. Okay, so this is dynamic, right? So every time I do literally anything here, it updates everything randomly. That's fun for getting the numbers here, but we're going to want to lock that down. So here's how we do that. I'm going to select everything. I'm going to copy it. And then I'm going to paste it back. Oops, sorry. I'm going to paste it back values. Okay, paste it back the values. And you'll see now when I go through this, it's now saying not rand between, but just the numbers. And you can see I can now do things, and it doesn't change it. So this is locked in now. I'm going to save that. Okay, so we've got our data right here. Now we want to put it into the problem. So I'm going to come back over to this problem. And what I'm going to want to do is I'm going to want to go up over here to mailings, and I'm going to say start mail merge. Actually, I'm not going to. I'm just going to say select recipients. Use existing list. Now, the language of mail merge, this comes from the idea of making form letters. Basically, it's all about, to John Doe, we have a great offer for you, blah, 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 and they can just basically have the same text but different names. That's where the terms come from. We're basically not using it in that form, but just know some of the terminology will seem a bit weird. Use an existing list. Okay, now I've got to go up and find it. It's in my documents and the data for problem set number 1. Boom. Okay, so now I've got merge fields that I can insert from up here. See, I've got version, mass, number, and bin size. So at the top, I'm just going to say version. And then I'm going to go back to mailings, insert merge field, version. Merge field, version. Oh, yours probably isn't going to look like this right now. It'll probably look like that. Okay, we'll get into what was just happening there in just a second. Version. Okay, now I'm going to change these numbers here. So 5.8, I'm going to say, and actually before we even do that, let's preview the results. Boom. This is the first one. Second one. Hey, that's looking good. I'm going to turn off the preview for a second here. Okay, then I'm going to insert a merge field. It's mass. Boom. I'm going to change the 2.3 to be the number, and then I'm going to change the bin size. Insert merge field bin size. Boom. Okay. Looks good. Looks good. Let's preview the results. Uh-oh. Oh, no. Right? If I look through this, we got some weirdness happening here. We got these, like, super long decimals. I don't like that. This is something to do with floating point. I don't know. It's something to do with the way numbers are calculated and transformed in here. You can see nice round numbers like this work out fine, but anything with a decimal comes out really ugly. So anytime we do any calculation, including that dividing by 10, we end up with this weirdness that we just kind of want to solve. So there is a solution here, and it's kind of ugly, but I will tell you it, and then everything's kind of beautiful. So what I'm going to do is I'm going to hit Alt F9. And you might have to hit Alt and the function button on yours, Alt function F9. Now you can see I've got a more fancified version of this. Okay? So I go to, now what I can do is I can add, I don't know, some sort of toggle thing here. So the key thing we're going to want to do is hit \number, and then tell the precision that we want from this. So the mass, I want 2 decimal precision, 0.0. Now the 0, that says I want to 1 decimal place. Okay. The number, again, I want to 1 decimal precision, so /number 0.0. And the bin size, I actually wanted to 1 decimal precision too, right? I wanted 100.0. Otherwise, we could end up with a situation where got a sig fig of basically 1, and I'd prefer not that because that will make my answers kind of silly at the end. So /number 0.0. You can look up online all the different, you can do a whole bunch of different stuff with these, but these are the ones I use pretty much every time. Okay, so there we go. Now I've got to hit Alt Function F9 to get rid of that. And now let's preview the results. Hey, that's looking right. Okay, so now we've got something, and I can now look through these, boom, 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 and you can see I've got so many different versions of it. Love it. Now I can finish and merge. I can print the individual documents either to a PDF, or I could actually just print them off to the printer, which is what I usually do. And I can save this, and it will keep it as a whole thing. So each time it'll ask me what the file I need to merge it with is. So that's basically how I make these. Okay, so that's the first step. We have now made 25 versions of this problem. First step done. But that's actually the easy step, right? Because I could have done that by hand. It would have taken me a couple minutes longer. But I could totally have just gone through and edited each one of these. Here's the beauty thing I want to focus on. How do we now take this and solve it in Excel? Well, let's come back here. Now we've actually got to do some math. Okay, that's kind of fun. So usually I leave a break here and I say solution, just to let me know what's going on here. I'm doing this in the exact same file I'm doing here. Now, because I've got this open here, it might not let me open there. So I'm just going to save this now for what we got there, and I'm going to close that off. Okay. Now, what I'm going to want to do is not just get an answer. I'm going to want to have the intermediate steps. So when I'm looking at a student's work, I can be like, oh yeah, they got that part, but they didn't get this part, or whatever it is. Again, I'm going to go through these and mark these by hand, marking in a fairly complicated way, as we all do, looking at how they're thinking and all of that sort of thing. I'm not just going to look at the answers and give checks. But these will make it very easy for me to see how they're doing. So let's see. First thing we want to do is we want to find... what do we want to say? Maybe the number of grams produced per day. Grams of pencils per day. Now I'm going to make this bigger just so it fits in one. Okay, so that's going to be the mass times the number. Remember, times 10 to the 6th, right? So equals this times this times 10 to the power of 6 equals, boom. That's grams of pencils produced each day. And I can just, I'm going to have to drag this down because there is nothing to the left here right now. Boom, drag it down. So each problem I've now calculated the grams of pencils per day. Okay, then I'm going to say the, how about pounds of pencils per day? Okay. Equals, okay, it's going to be this amount divided by the number of grams in a pound. This one divided by 454. Boom. The pounds of pencils per day. And now because I have something to the immediate left, I can fill it in. Boom. Okay, how's the next thing we might think about doing here? Grams of pencils per day, pounds of pencils per day, bins of pencils per day. Would be equals this amount divided by whatever that bin size was. Boom. Again, I'm probably going to want the students to be answering these questions with some sort of formal sort of unit conversion stuff, but for Excel, I can do the calculations right here. Okay, grams of pencils per day, pounds of pencils per day, bins of pencils per day, and then it's bins of pencils per year equals simply this times 365. In which case, I fill that in. And there we go. And now I can basically, for any version, I can look it up and I can immediately see, coming along here, boom, and I can select it nicely if I just click right there. I can see not only the final answer that they should be getting, but all the intermediate steps. Now, the decimal precision might be higher than they'll actually do, but this is actually going to be the exact right amount. So anything else is slightly off. So that's basically how I do it. I find this works really well. It gives students challenging problems. It encourages them to work together without sort of copying each other. Like I say, I find this very useful for me. Got to play around with Excel a bit to get it to useful. Like I say, that Alt F9 trick and changing it so that you've got the exact right amount of decimals that you want. That's an important trick here. But yeah, if you got anything useful for this, or if you find anything cool with it, or if I made some mistakes in this, that's totally possible, just let me know in the comments. Thank you very much. Have a good day.